let's show that this property for determinants, which tells us that the determinant of the product of matrix AB is just equal to the product of the determinants of A and B. Now, in one of the playlists for this idea of properties, laws, and theorems, we tried to consider all types of matrices, I mean in terms of sizes, as we show for, say, example, commutativity and the rest. But here, since we're talking about determinants, and there's only one simple formula for determinants, that's for 2 by 2 matrix, we are going to adopt that because we cannot really show here the entire proof of this as we take on different sizes of matrices. We can, but it will not be enough for this presentation. So again, let's just stick with the 2 by 2 matrices here. This would be the limitation for this video. Please bear with me. That is because if you have a certain matrix M, in which components, let's say A, B, C, and D, the determinant of matrix M can be computed in this manner. The product of A and D, A minus B and C. So this is possible for a square matrix, specifically by 2 by 2 matrices here. Since we have this formula, let us try to adapt this in showing that the determinant of the product of A and B is just equal to the determinant of A times the determinant of B. Before that, let's try to assume representations for matrix A and matrix B. Let matrix A be a matrix of components of A. Okay? Again, we are just on 2 by 2 matrices. So A11, A12, A21, A2, and 2. And B would be for B. You have B11, B12. We also have here B21 and B2 and 2. So let us show that with this representation, this is true. So let's try first with A and B, as this is the product of the 2 matrices. Okay? When you talk about the product of 2 matrices, this is defined because the product, the size of A is a 2 by 2 matrix and B is a 2 by 2 matrix. In short, the result or the resulting matrix is also a 2 by 2 matrix. Since it's already defined, we can have the product now. A11, A12, A21, A2, and 2 times your B, which is B11, B12, B21, B, and 2, 2. By the way, take note that we are dealing with the product of matrices, and commutativity for multiplication is not true for all. Okay? That would mean if we have the product of A and B here, it should be in this manner, and the determinant of A first times the determinant of B. And of course, this is commutative because it's under multiplication, but this is not necessarily commutative. So please bear with that. So the product of that is, of course, the product, that's A11, B11 plus A12, B21. You have this row times this column. Now, this row times this column, A11, B12 plus A12, B2, and 2. So for this now row, multiply to that, A21, B11 plus A22, B2, and 1. Then you will have A21, B12 plus A22, B2, and 2. Okay, so hopefully we could reach here. But of course, now let's talk about the determinant. I don't have much space. Let me use here. The determinant of A and B using these representations. Again, we have this formula, the product of this minus the product of that. So we're going to multiply these two minus this one here. This is equal to, we have A11, B11 plus A12, B21 times this A21, B12 plus A22, B22. This is minus the product of the other diagonal. I would like to write this first because that's B and C. So A11, B12 plus A12, B22 times this here, A21, B11 plus A22, B2, and 1. So let's try to multiply them, okay, so that we could have a final form later if it's possible. So you have multiply FOIL method. So yeah, I'm just going to write parentheses first. So this multiply to that. So A11, let's start with all the A's. A21, B11, B12. Outer, so you have plus A11, A22, this one here, B11, B2, and 2. Right? Then plus inner, you have the inner here, A12, A21, B21, or B12. Let's start with B12. Let's arrange it with its order, B21. Plus, let's have the last, A12, A22, B21, B2, and 2. This is just for this portion, okay? Minus, now let's have this one in here. So let's have a grouping so that the negative will be applied to all later. So this and that, these two first. A11, A21, B12, B11 first, B12. As you can see, you will have already the same, so it will be deleted later. Plus, you have the outer, this one here and here. A11, A22, B12, B12, and B21. Plus, we have the inner, A12, A21, B11, and B12. Sorry, B22. B11, B22. Plus, we have the last, A12, A22, B21, and B22. So same here as well. So since we're applying the negative right now, this would be equal to A11, A21, B11, B12, plus A11, A22, B11, B22. We're still writing the first group, A21, A12, pardon with that, A21, B12, and B21, plus A12, A22, B21, B22, minus. So we're going to apply it on all terms here. A11, A21, B11, B12, minus A11, sorry, A22, B12, and B21. Okay? Minus A12, A21, B11, B22. This is now minus A12, A22, B21, B22. As mentioned, this will be cancelled. A11, A21, B11, B12. This also be cancelled. A12, B20, A22, B12. So we are left with this. Hey, take it that our goal is we are going to reach the product of determinants, and we are not yet there, but we are getting closer. So let's start with A11. Okay, A22, B11, B22 from here, and here you will have plus A12, A21, B12, B21 as well. Then this is minus this one here, A11, A22, B12, B21, minus A12, that's 1, 2, A21, B11, and B22. So what is now the next move? Take note that our goal will be the determinant of A and determinant of B. You can also try using a separate piece of paper showing what will be the determinant of A and B using this. So we have these expressions here. I don't know if it's okay with it. I will write it here. Okay? The determinant of A, using this concept, using the entries here, this is equal to A11, A22 minus A12, A21, right? product of this minus product of that. For determinant of B, you have B11, B22 minus B12 and B22. So take note of that. Why am I writing this? Because our goal from this expression would reach a product of this. That would mean there should be a way for us to factor this and that from here. And what would be our next step? Now, if we are still confused with this, take note that here we need to have A11 and A22 together. We have here A11 and A22 for the first and for the third. Okay? So we can rearrange them. That would also be true for our B11 here. And in the other form later. So let's just simply look into that first. And for our A, you have A12 and A21. So you have here A12, A21 as well as here. So we can rearrange them so that we could factor that. So you have A11, A22, B11, B22. Let's have it here minus A11, A22, B12, B21. Okay, so we have grouped that now. This one here plus A12, A21, B12, B21 with this minus A12, A21 with the same entries here, so we can factor that later. B11 and B22. Now talking about factoring this and this one here, so we're going to factor that A11, A22. So you will have B11, B22 here. Since you're removing this, this is what is left, B12, B21. Okay? Similarly here, let's factor this and that. Plus, if you would like to, they can use, let's just simply use plus, if it's okay. No, let's use difference. Let's use difference. Why? Just for us to what do you call this one, to represent this pattern as well. And if we are going to factor negative here, this will become plus. So this follow B12, B22, B1, 1, 2, 2, 2 here. So once we take out the minus A12 and A21, not positive but the negative, this positive, so that's negative B12, B21, it's 2. This will become plus B11 and B22. You can rearrange that to make it like this. So we have A11, A22, B11, B22 minus B12, B21 minus A12, A21. Rearranging this, B11, B22 minus B12, B21. Why do we do that? So that this is common to both. So we can factor that. So we factor that B11, B22 minus B12, B21. Once we take it in both, you will have here A11, A22 minus A12, A21. And what is this, by the way? This again, this would become determinant of B. The second about A's will become determinant of A. But since this is a structure, and I already mentioned earlier this is commutative, but let's just make a goal to reach this. So since it is commutative, let's rearrange that too. But you could also rearrange the determinants later if you would like to. Let's just rearrange this so that it could pattern to our final form. Okay, so what is this? And what is this? As mentioned, they are both determinants. So this is actually just equal to the determinant of A times the determinant of B. To which, here earlier, this is actually the determinant of B and times determinant of A. And under commutativity, you can have it like that. But since this is our goal, I'm just showing you that method. So this shows now that from here, it's just equal to this one. This shows the determinant of the product of two matrices which is defined. The product is defined. Make sure that the product is defined. This is equal to the product of the determinants of the original matrices. So see, this is very long since it needs to be illustrated well. So this is about properties, laws, and theorems. Please subscribe now.